6.3, square root functions and inequalities. So this lesson's all about learning a new function, the square root function, which is this function. So it's all about the graph of it. As always, I like to make a graph by making a table. So my table is already set up. Let me make my grid here. I really wish it came with like grid lines. That would be great. But you know, whatever. Anyway, so I have these values. I'm gonna add a couple more values in here. So let's go 4 and 9. Add those, and you'll see why in a second. So square root function, right? So let's do square root of -2, and we can't do that. Now you could say, oh, we plug it's I rad 2, and I was like, good job, but we can't graph I on this, right? This is x and this is y, so we're just gonna go back to like no solution there. Square root of -1, same idea. We get an I, but can't graph it on here, so there you go. No value there. Probably should just put like line. Square root of 0 is 0. Square root of 1 is 1. Square root of 2 is like 1 point blah 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 blah. This is why I put 4 and 9. So I know square root of 4 it's 2, and the square root of 3 is 9 is 3. So I'm gonna use those values. So we start at 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 1, 1. 2, a little bit more than 1. At 4, I go to 2. Yeah, that's a little lower. And at 9, I go to 3. So my graphs look kind of like this. And that's what absolute value graph looks like. A basic absolute value graph. We can add it to our table of graphs. It's kind of like this. And let's talk about domain and range real quick. Domain, notice we can't do negative values. It starts from 0 to infinity. So I brought that up before. And my range also starts at 0 and goes to infinity. So that's the basics of a absolute value function, a square root function, sorry. Looks like that, and that's my domain and range. So that's how you do domain if I give a graph. Now, if you remember how I do the domain, if I give you an equation, well, this has to be positive, no negative value, so x is greater than or equal to 0. If I give you an equation, that's how I find domain. Just set the inside part greater than or equal to 0. So for like this one, my domain, so that inside part greater than or equal to 0 divided by 4. My domain is all numbers greater than or equal to 0. Next one, same idea. Domain, get the whatever's on the inside so that greater than or equal to 0. Add 5. My domain is x has to be greater than or equal to 5. Last one here, same idea. There's a -2 that actually affects the range. My domain is this part. So it's all about the stuff underneath the radical. So x plus 8 is greater than or equal to 0. So my domain is x is greater than or equal to -8. So, right, domain and range, you could do it like we always do if you have a graph. Just look at the x values, range is the y values. If I give you an equation for domain, remember, domain's always the same thing. If it's a fraction, you cannot divide by 0. If it's a square root, the inside has to be greater than or equal to 0. If it's anything else right now, it's all real numbers. We'll learn some more later, but for now, it's all real numbers. If it's anything else. That's how you do domain. And like everything else, let's talk about the basics of graphing, right? So again, the basics for a function looks like this. And like we've been doing from chapter 2 on, once you know the basic graph, then it's doing transformations is always the same thing. Inside's the x, and you do the opposite. So you're going to go left or right. Outside's the y. And you follow. So it lets you know if you go up or down. And then the A is also on the outside. That's your vertical stretch, vertical shift, right? So vertical stretch if it's greater than 1, and shrink if it's less than 1 or 0. Okay. One other thing, positive A looks like this. A negative A, remember you flip it down, so it'll look like this. Open down instead of up. So that's the basics. Let's do some graphs. let me start with putting the little tape, the little thing there. Okay. Now let's talk about this, right? So inside opposite, outside follow. So inside opposite, inside x opposite. There's nothing there, so it's just a 0. I'm gonna start at 0. Outside y follow, so down 2. So 0, -2. This whole thing's moving down 2. So I'm gonna be right here's where I'm starting. Again, we're just doing a sketch, so it's a square root function, so it's gonna look like this. Ooh, not very good. There we go. Something like that. So that's my square root graph. Now they want to do domain and range. So remember, domain is x, range is y. So domain, x values, where do you start? Right here. Start at 0 and go all the way to infinity. Bracket because it's a closed circle. Parenthesis because infinity can never touch. It's always a parenthesis. Range, lowest to highest. My lowest is right here at -2. My highest is arrow, which is always infinity. So my range, -2 to infinity. Again, you can also just do it by looking at this. Anyway, next one. Right, so again, where do I start? Inside opposite, so 1. So we're going to go right 1. Outside fall, there's nothing out here, so 0. And then I have a vertical stretch of 3. So I'm going to go 1, 0, and a vertical stretch of 3. So you kind of treat it like slope, but it's not really going to be slope like 1 and 3. It's not going to be higher than normal. I kind of think about it like a slope over 1 of 3. You know, it's not totally correct because it's not a linear line, but gives a good basis to draw it. So that's our picture, especially if we're doing a sketch. Domain, again, you can look at the inside and go, okay, +1, so x greater than 1. Or you can look at your graph. Start at 1 and at infinity. So 1 to infinity. My range, we're starting at 0, low to high, and ending at arrow, infinity. So that's the graph. That's my domain range. Next one. Alright, so this one, let's make it fun. Let's make it a negative. Okay. So again, inside opposites, we're gonna go left 4, outside follow, we're gonna go down -1. So that's kind of where we're starting. -4 and -1. So -4, -1. Now, this is a shrink, right? So vertical shrink, it's less than 1. Not the fact that it's negative, the fact that it's less than 1. The fact that it's negative means it's open down. We're going to open down, not up. So it's going to be like down 1 over 2, if that helps. Again, not exactly, but it gives you a good basis. So kind of like this. That's our graph. Domain and range. Remember, domain is the x values. So where do we start? At -4, and we go to infinity. Range is the y values. What's the lowest? The lowest I see is an arrow, so -infinity. Highest I see is -1. So get low to high, so -infinity starts to -1. That's our domain and range graph. Okay, let's do this one. I want to change something about it though because it's not written very well. Ooh, that's even worse. 3x minus 6 plus 5. Okay, so this is what I want to do. That's why this one's, I don't want to get into the ugly fractions. So here's a key thing about this. When we talk about our shifts, that's supposed to be a C. The x has to be by itself. So actually the first thing you gotta do is factor out the 3. So it's going to look like this. So now I know, oh, okay, I'm moving right 2, I'm moving up 5. So that's why we're right 2, up 5. So I'm going to start at 2, 5. Now what 3 does, remember what that does? It's a horizontal shrink. And it's that opposite, so not stretch, it's a shrink. Up 3. So horizontal shrink of 3. So you can horizontally, you can shrink at 3. And don't forget there's a negative on the outside, so it opens down. So if I was going to graph this, start at 2, 5. It's opening down because it's a negative on the outside, and it's a horizontal shrink of 3. So we're going to shrink it horizontally, so it'll be a little bit wider, kind of like that. Again, this is a sketch. If you want to see a good example, you could do a Desmos picture of it. But that's what it looks like. Domain, real quick, 2 to infinity. Range, my lowest is an arrow, so negative infinity. Highest looks like it's 5. So that's some basic graphs. This is practice graphing of square root functions. Now let's go backwards, like I always love to do. Right, so if we're going backwards, we got to understand a couple things, right? Our basic graph looks like this. And now, right, the stuff on the anything that's out here moves it left and right. Anything out here moves it up and down. So look at this graph. We're starting at negative 2, 4. Inside opposite, so this is going to be plus 2. Outside follow, so plus 4. So that's our equation. X plus 2 plus 4 on the outside. Look at the application problem. It's the same thing. This field that a two-tsunami or tidal wave can't travel is modeled by the equation of this. So that's our equation. Again, you have to know what your variables are. V is the speed, and D is the average depth of the water. A tsunami is found to be traveling at 145 kilometers per hour. That's the speed. They're giving us V right now. So we're going to plug that in for V. So it's going to be 145 equals 356 rad D. What is the average depth of the water? So we got to find D. So all we do is solve for D. Divide by 356. So you get 145 over 356 equals square root of D. And remember the way we get rid of the square root is we square both sides. It's the opposite operation. So whatever that squared is our answer. I guess I need a calculator for that. That would be parentheses. Oops, get out of that. Parentheses 145 divided by 356 squared. So about 0.166 kilometers. So that's an application problem. Now let's talk about how to graph inequalities. That's another application problem. We're going to skip that one. Let's talk about how to graph inequalities. So it works the exact same way as everything else, right? We shade the line, right? If it's like this or like this, you do a dotted or dashed line. If it's greater than or equal to or less than or equal to, then you do a solid line. Shading. Always two ways to do it. Test point, or if it's in proper notation, then we could do greater than or equal to is above, less than equal to is below. Again, this only works in proper notation. So let's do this first one. So first graph, right, it's moving up 4. So 0, 4 is kind of where I start. So no left or right, just up 4. So 1, 2, 3, 4. It's a closed circle because it's solid. So like this. I mean, it should be a solid line because it has a line underneath it. And then this is in proper notation, so I could shade above. Now we got to watch out though, because you can't just shade the whole thing. Because my graph doesn't start over here. You got to kind of start right here, where your graph starts. So this part gets shaded, and that's it. Right? I can't go all the way down there because that's not part of my answer. It's no solution over there. So it's just that part. Let's do a couple more just to practice. So this one, right? So I'm going to start at inside opposite, outside follow. So 6, 2 is where I'm starting. I'm going to draw a solid line because that's equal to. And then again, to basic graph. So we're going to go like this. Basic sketch. Now this one's less than, so I got to shade below. So again, if you're not sure, you can do a test point, but you want to do a test point either above the line or below the line. So don't pick a point over there, because that's not even within the domain. So you got to pick a point like 7, 1 or something. Point right there and try that. In this case, I'm going to go to less than, so I'm going to shade below. So again, below is all this. So you get like that. Couple more. This one right here. Inside opposite, so -3. Outside fall, there's nothing on the outside, so 0. So -3, 0. -2, that's a vertical stretch. Right, so it's a vertical stretch. But it's also opening down because it's negative. So it's like down 2 over 1 type of thing. And it's dotted because it's a not equal to sign. Then we're shading below, so less than. Less than, so below. And then the last one, again, another one we kind of talked about earlier. If you have a 2 right there, you can't leave it there. You got to factor it out. So it's going to look like this. Now, how do we factor out a 2 from a 1? Well, here's a trick. There's like a note. What's that trick? You can factor anything out of anything. If I gave you 3x minus 5 and I was like, hey, I want to factor out a pi. You can do that. Just put pi on the outside. And what happens when you factor? You divide. Just divide these by pi. Boom, we just factor out a pi, right? If I give you 2x squared plus 4, and I'm like, no, factor out a 10. You can do that. Put a 10 on the outside. Divide these by 10. So x squared over 5 divided by 10 plus 2 over 5. You just factor out a 10. You can factor anything out of anything. Just divide by it. So if I'm factoring a 2 out, so divide that by 2. -1/2 minus 3. Right? Now I know my graph. I'm going to start at inside opposite, 1/2. Outside follow, -3. So 1/2 and -3. And again, that's a vertical shrink of 2. So a vertical shrink of 2. So it's going to be thinner than normal. Something to that effect. It should be dotted though, not solid. I messed that up. And then shade above. So again, don't go past the domain. So like that. Anyway, that's the lesson.